Hey everyone! In today's video, we're talking about hybridization, the process where atoms mix their orbitals to form molecules. This is what determines the 3D shapes of molecules. Let's dive right in. Now that we've got the basics of hybridization down, let's define it and understand why it's so important in chemistry. Hybridization is the process where atomic orbitals mix together to form new hybrid orbitals. This allows atoms to bond in ways that are more stable and suited to forming molecules. So, why does hybridization matter? Well, it explains how molecules take on specific shapes and bond angles. Understanding hybridization is essential for predicting how atoms will bond in different molecules, and it helps us figure out their chemical behavior. Now, let's talk about the shape of methane. When carbon undergoes sp3 hybridization, it forms a tetrahedral shape. The four sp3 orbitals spread out evenly around the carbon atom. This shape places the hydrogen atoms at the corners of a tetrahedron. The bond angles between the hydrogen atoms are about 109.5 degrees. This specific shape helps reduce repulsion and makes the molecule stable. Let's talk about sp2 hybridization using ethene C₂H₄ as an example. In this molecule, each carbon atom undergoes sp2 hybridization. This means the carbon mixes one s orbital with two p orbitals to form three sp2 orbitals. These three sp2 orbitals bond with two hydrogen atoms and one carbon atom, giving a trigonal planar geometry. But there's more. One of the p orbitals remains unhybridized and overlaps side by side with the p orbital from the other carbon atom, creating a pi bond. This forms a double bond between the carbon atoms, adding extra stability to the molecule. Overall, sp2 hybridization results in a flat planar molecule with bond angles of 120 degrees. This is the structure of ethene. Let's look at sp hybridization using acetylene C₂H₂ as an example. In acetylene, each carbon undergoes sp hybridization. This means each carbon mixes one s orbital with one p orbital to form two sp hybrid orbitals. These two sp hybrid orbitals overlap to form two sigma bonds, one between each carbon and a hydrogen atom, and another between the two carbon atoms. Now, what about the other p orbitals? Well, each carbon has two unhybridized p orbitals, which overlap sideways to form two pi bonds. These pi bonds create a triple bond between the two carbon atoms. As a result, acetylene has a linear shape with bond angles of 180 degrees, giving it a straight line structure.